This conference will now be recorded.
Good morning, everyone. Can you all hear me clear?
Yeah, we can hear you.
Do you all see my screen? Please confirm that as well.
Yeah, we can see you.
Great, thanks. All right, then let's get started. Hello, everyone. Uh, my name is Kiran. Thank you for joining the demo. So let's get started again. So about me, first let's talk about me. So I have about 10 years of experience in DevOps and site reliability engineering. I'm passionate about technology and teaching, training. Mm, I watch a lot of movies and sometimes read books. And my areas of interest, particularly from the technology area, is container orchestration, cloud automation, and I'm very much a fan of Linux and free and open source softwares. So that's about me in a nutshell. Moving on. So without any further ado, let's talk about this course. What are we going to learn in this course? Okay. So at a very high level, what are we going to learn is the following. Okay. Understand IT architecture and software development lifecycle. How does IT architecture looks like how do you architect a solution like a web application, okay, from a theoretical perspective, and what is software development life cycle, like what are the various stages involved in developing any software application, okay, and learn key Azure services. Of course, the course itself means DevOps with Azure. That means we are going to learn key Azure services. Okay, we're going to learn many services from Azure, from uh, access control to virtual machines, virtual networks, storage, okay, DNS, and a lot of other things. Gain in-depth understanding of DevOps as a practice. So we'll understand what DevOps mean, okay, what DevOps means and what how is it applied in real world. And of course, we will do a lot of hands-on with DevOps toolset. Where are we going to do all this? On Azure infrastructure. Okay, of course, there will be a lot of automation. Okay, so learning about infrastructure and everything is fine, but unless you find you don't know how to automate it, you might not be um, in a very advantageous position in the job market. Okay, so it's all about automation. Call it DevOps, call it SRE, or any other practice. It's all about automation. So we are going to do a lot of it. All right. So yeah, before I move on to explaining about some of these high concepts at a very high level, I would like to state some ground rules. If you have any questions, please feel free to interrupt me and ask. You do not wait till the end. Okay, that's one that will keep the session engaging. Second one, but if you're not speaking, please make sure you're on mute. Okay, that's it. That's all I have as a ground rules. All right, let's move on. So now let's understand about cloud. So you all might have heard this term at least once. So what does the term cloud mean to you?
It is a software.
Okay. Any other answers?
Cloud is like a platform or a hosting environment. Uh, we can term it as like uh, a, a superstructure which connects the whole server side environment, which can offer
Hmm.
different services like uh, servers, computing, memory, and everything. It's a connected environment spread throughout the world.
Great. Okay. Anyone else? Anyone else wants to answer?
Yeah, it's kind of like virtual storage area.
Okay.
It's a platform where
Hmm.
you have
One is that.
everything in one platform. You know, we used to have virtual boxes in separate place. We used to have projects or different places, but right now the cloud is everything.
Hmm.
Where VPCs, securities, everything in one platform, so that you can set your project in one go and you can access anywhere from the world.
Okay.
Yeah, so cloud as such, it provides the infrastructure as
Hmm.
well as the platform as well as the software services. So it provides a different level of abstractions uh, to the companies so that they can use the cloud infrastructure. That
Okay.
is one thing, and it reduces the lot of the infrastructure costs, and it has a lot of flexibility in terms of pricing and in terms of operations, and it reduces a lot of efforts in maintaining the IT admin staff, a lot of things, and it provides a lot of software services.
Great. Okay. Okay. Thanks, everyone.
It's an open platform where
Mhm,
we can use all the services which are related to the any system, like in a hardware, applications, software, and
mhm,
it's easily scalable, and then it can expandable. It's an open platform kind of thing, and it's easy
mhm.
to maintain by the third party, and then it's scalable, and then it can be customized any softwares required as and when on demand.
Okay. All right. So all of you are right. Uh, so let's see what's the standard definition. Okay. So cloud computing is the on-demand availability of computing resources. Like all of you have said, it's about getting the resources on demand. Okay. But what does a cloud entail? What is it underlying? Okay, it's nothing but as some of you has already pointed out, it's nothing but a collection of. Yes, someone has anything to say? All right. Okay. So cloud is collection of data centers managed by a cloud provider. Users can rent resources on a pay as you use model. Yeah, we'll come to that. So before that, the on demand availability. Okay. So let's talk about a real life example again, which is also powered by cloud only. Okay. So back in the day, when I say back in the day, let's go about 10, 12 years ago. If you have to book a cab, okay, from your place, let's say you live somewhere in Begumpet in Hyderabad, and you need to book a. Okay. Back then, yeah, the international airport was still there. Okay. Let's say you have to book a cab from your Begumpet to international airport, which is in Shamshabad. Okay. So if you have to book it for 30th, on 29th itself, you have to call these you know cab providers like Skycab, or who else do we have? Back then we had Dot Cabs and all these other cabs, right? So we had Z Cabs. If you're old enough like me, you remember those things. So you have to call them and ask them, okay, can you schedule a cab to Shamshabad for tomorrow at 11 a.m. You have to come at so and so place and pick me up. Okay. Then the dot cabs or sky cabs person checks his details wherever, whether he's maintaining in an Excel or a notebook. He will cross check and say, oh no, tomorrow we have everything booked. You don't have any cabs. Then you have to go to Z cabs and ask them. Then you have to go to Sky Cabs, Meru Cabs. Okay, these were the cabs back then. So you have to ask them, do you have a cab for 11 a.m. from Begumpet to Shamshabad? It was a real big pain. Okay, you have to book it 24 hours in advance. Okay, no last minute changes. So kids these days don't know how it's difficult to travel back then if you don't have your own vehicle. Okay, so the point I'm trying to say is that was the scene there. Now today, look at this. If you have to go somewhere, okay, even to the next street or even to the farthest place in the city, you can just log into Uber or Ola, and within a few seconds, right, maybe minutes, you can book a cab and the cab comes to your doorstep. Okay, this is what we call as on demand, just like whenever you want. And here there is no third party intervention. There is no other person who you're talking to. It's only the app with which you're interacting till you get your cab, right? So it will get you the cab. You're interacting with software and it gives you the cab, and you you apply with that particular cab. Similarly, cloud computing is like that. Okay, imagine a scenario, okay, where um, you have a beautiful idea to start a web website. Okay, let's say you want to start a website which talks about some family games. Okay, which has some video functionality linked in like Zoom, and also another pane where you can play games, okay, side by side with your family members. Okay, and you could also share notes or share recipes. I mean, it's like a social media site, but only with much privacy and only for your family. Okay, so let's say you have that beautiful idea. You start a web. You want to start this website. You tested with your friends. It kind of worked well. Okay, I mean, locally they installed and tried some checks and everything is working good. Now you want to install it on server because you have to make it available for everyone. Then you cannot host it just on your laptop or desktop. You need to have a server. So you have to buy a big server. Okay, so which means a physical box like your CPU towers back in the day, and you have to keep it in your home, and you start deploying your code on the server. But even before your application is going live, you have to spend almost 3 or 4 lakhs just to buy this one physical server. Okay, then you bought the server, but you want to make it available 24/7. Even before you know people like it or not, you have to make sure it is available 24/7. People, you never know when who is accessing it. You might make it popular through social media. Okay, so you have to make sure there is always uh, excuse me, redundant power, meaning you have to put some inverter or a generator so that even if your main power line is gone, that is there. Also think about your internet connectivity. Internet connectivity could always go down, whether it's in India or the US, anywhere. um, the probability might be less in US, but it still goes south, right? So you need to still have a secondary power line, secondary cable connection or network connection. Okay, so just before even you start the application, you have to spend so much of time. Okay, and by initial days you see a lot of traffic coming in and people are really enjoying it, but your one server is not enough now to handle all the traffic. Okay, so then you'll have to buy another server, and when you have two servers, you need to have something called as a load balancer, which distributes the load between these two machines. Okay, so just before even you started your business, or your application really got some sponsor, because all this right now is happening without any return on investment for you. If website has become popular, but you need ads and other things, even before you went to that stage, your application, I mean, you spent already a lot of money. And let's say after a few days, because the lockdowns are over and hoping everything gets back to normal, people forget about your website, and now you have lot of dead investment. Okay, you have two big physical servers you bought, you have the routers, you have the load balancers, everything you bought, and they're all lying idle at home. Okay, of course you could resell in the market, but still it was a capital expenditure. Even before you get anything, you have to spend a lot of money. But fast forward to today, if you have any idea, you can log in, you can create an account in any of the cloud providers, maybe AWS, maybe Azure, maybe Google Cloud Platform or DigitalOcean, anywhere, and start your application. Okay, in a few minutes. You already, I mean, of course, as a developer, you might have already worked for so many hours in building the application, or your friends might have worked on the building. All that you just need to do is upload this code to any of the virtual machines available in the cloud, some of the cloud operators I mentioned, and your application is ready in a minute. And there are no upfront cost. That's what it means, meaning if you have to start running your application, you don't have to spend any money. You will pay the bill only for the amount of servers you use at the end of the month. Okay, not at the start of the month. So there is no upfront cost. And also this is pay as you use model, just like your Ola and Uber. Okay, back in the day, again, if you have to negotiate with the cab drivers or the auto drivers, the auto rickshaw drivers, you have to, it's not about the distance, it's more about what he wants. Okay, or maybe a lot of other factors, like I will not say that, based on his mood, but yeah, it's a fixed cost, right? It is decided even before you start the journey. But today it's all about according to the distance you travel. Okay, if you're traveling only for 10.1 kilometers, you will be billed only for 10.1 kilometers, right? If you're traveling for 10.9 kilometers, he will not bill you for 11 kilometers. He will exactly bill you for 10.9 kilometers. Okay, and also as per the time, of course. Okay, so similarly in cloud also, that the same thing happens. For example, take the same scenario, but this time you're doing it on cloud. So you built it on one virtual machine and you ran it for 15 days. So for the first 15 days, you will be billed only for that one virtual machine. After you notice that a lot of people are accessing your website, you decided to increase your servers. So you put a secondary virtual machine. Now you put a load balancer also. So at the end of the month, you will be billed for two machines for 15 days, from 15th of the month to end of the month, and also the load balancer from 15th. But for one virtual machine, you'll be billed for the entire month because you have been using it from the start of the month. Okay, that's how your billing will occur. Billing will happen. It is very granular. And let's say you increased your servers to, more and more people have started coming to your website. You have increased this number of servers to, let's say, 10 servers. But again, after some time, the load goes back. As I said, let's say lockdowns are easing, people are going out, started working, school started. So this application is losing its steam. So less number of people are using it. So now you can just delete the additional, I mean, you have 10 virtual machines for your application now. You can, let's say the load has come down, you don't need so many virtual machines. You can delete the 5 virtual machines and forget about them. And you will be billed only for the remaining 5 virtual machines. Okay, for the rest of the time whenever you're using. Okay, that's one of the very important aspect of cloud computing. Okay, that's what some of you has also highlighted, the scalability. Okay, if you have to, let's say, let's forget about individual user, let's forget about our hobby website. Let's say it's a large organization. Okay, and they're planning to start a new application. Okay, let's say Citibank is trying to start a new online application, or new website plus mobile app, which is exclusively for sharing, trading and cryptocurrency, let's suppose. Okay, so when they have to start that, if they have their own data centers, even if it's a large organization like Citibank, they have to procure the hardware, the servers, the physical machines. Okay, so for that, they'll have to raise a tender, they'll have to wait for the quotes, okay, whatever their procurement process is, and it will take a few days. Okay, uh, imagine about a startups. If it's a startup, they might not even have so many contacts. It might take even more days for a startup to get the servers, if they are maintaining their own servers, to buy them and to configure and all these things. And again, if they are not being used for whatever reasons, they will lie idle in your data center, and you have to anyway keep maintaining it. You should make sure these are functioning and updates and all these things. But in cloud, let's say you need a big machine for 1 hour to do some machine learning analytics. So you can simply create one big large machine with, let's say, um, 96 cores of 96 CPUs and 1 terabyte of RAM, and you can simply use it for 1 hour or whatever time you need, and simply shut it down and delete it, forget about it. Of course, you can store your data in a different location. But let's say your application, the ML module needs very high powered computer, then in real world, I mean, not in real world, if you're doing it in a physical data center, is it really possible to purchase that big machine just for 1 hour every week? Let's say it's not really worth your money, right? But in cloud, it's possible to create such a big machine and use it for whatever time you want. And when you're done, you can simply delete it. When you're deleting it, it means it is going away from your subscription. Okay, but you can still retain the data in some other location. Make sense? So that's another aspect, scalability. Okay, so it can scale very faster, within a matter of minutes at the most, and you can also scale down scale up and scale down. Scale up is increasing your resources. Scaling down is decreasing the number of resources or the capacity of each of the resource. Resource could be a server, what we call as a virtual machine, or a disk, or a network load balancer, or something like a virtual network. All of these are resources. Okay, now coming to Azure. Okay, so what's Azure? Obviously, yeah. Before we go to Azure, any questions on cloud? And another thing to note is, like some of you have already spoken. There are three types. Yeah, go on, please. Hello.
Kiran, one small question. It might be silly. You said that no number of CPUs and then GB of RAM.
Mm.
What do you mean by that number of CPUs are 16 or 100 CPUs or 1 TB? I mean, as
Okay.
per my
So okay. So when you buy a phone, mobile phone, what are the things you look for?
mm, ideally, what is the RAM size? It makes the
Hmm.
quick processing,
Hmm.
and then hardware capacity to storage. Mostly these two features. I mean, additional is complementary. These are the main two parts. I mean, the RAM and then
So
storage.
okay. So you're going to look at the storage, whether it's going to save all your music and movies and all that. Okay, and the RAM. So how is RAM measured?
It is 6 GB or
Yeah, in
8
terms
GB.
of GB. Yeah, in terms of GB only, right? Yeah. Only 90s kids remember that it was in terms of memory bytes. Yeah. So my
Actually, Kiran, I think
college
the
had
RAM,
computers which had
I
RAM
think
of
in
64 MB. Yeah, taking back in time. Okay, right. So this is what you look for, right? Storage and RAM. But there is another aspect you generally tend to overlook. For example, they say Snapdragon, Qualcomm Snapdragon, um, uh, 850 or something like this. Have you ever noticed these things on a mobile ad?
Yeah, we heard that. Yeah,
What
Snapdragon
is
like that.
this?
Yeah. Mm,
This is the processor, CPU, which actually does your processing. Okay, your RAM is useful to allocate memory to the running applications, but the processing is done by the processor. Okay, so um, like again, going back, you had earlier dual core or core 2 duo and quad core and all this. That means two CPUs in your machine. Okay, one processor but which has two CPUs. Okay, then today we have octa-core. Even on mobile phones you have octa-core. What does that mean? That means 8 CPUs, 8 cores or 8 CPUs, you could say, in your machine. The processor is single but it has 8 cores in that. Okay. um, so the number of CPU means the number of operations that can be done parallelly. Of course, even on a single core, your operations are done parallelly for us. But you know, see, you again, high school class. High school computer class. We were told that computers are working parallelly, but actually there is something called as time slicing. A processor can handle only one process at a time. When I say a processor, I mean to say a CPU. Okay, but it looks to us that it is processing both the things at the same time. For example, I have my you know um, all the applications running. When I do a alt tab, it looks like they are working at the same time. For example, I can play my YouTube and also watch something else, or play or do something else at the same time. That's because computers time slice. So the more number of CPUs you have, the more number of parallel processes it's done, and it is effective. Okay, so computers, when you're talking about virtual machines, you will storage is like you can also add later. Of course, storage can also be considered. So these are the two things you look at: the number of CPUs, okay, and the amount of RAM.
okay.
Okay, so
So
that's what I
both should be in sync, right? And CPUs and then RAM have certain synchronization between these two components.
yeah. Yeah, they work together. But if you're talking about the specification, the ratio, yes, there will be some ratio, like, but you can I mean, different applications need different ratios. For example, if you're using any uh, database, running any database software on a virtual machine, it would require more memory than CPU. But if you're running any web applications, the ratio should be like 1:2 or 1:4. Like if you have one CPU, you need to have 4 GB of RAM, something like that. If you have two CPUs, you need to have 8 GB of RAM. Of course, cloud providers offer you predefined sizes. uh, it's not very customizable, but yeah, I think it will solve all the business cases. They have huge number of types of instances or types of virtual machines
Got it.
you can
Yeah, got it
choose.
now. So each number of processes corresponding to the RAM means if one processor is allocated to 4 GB or 16 GB, the amount of GB RAM we are allocating, the processing speed will be increased.
um it's not like that. Okay, you need both of them. Okay, you need
Okay.
good amount of RAM and good amount of CPUs as well for processing. Like I told you, it, de- it depends upon the applications. Some applications need more CPU than RAM. Okay, some applications need more RAM than CPU. Okay, so it varies, right? So you cannot clearly say that you need, for every GB you need so much of, sorry, for every core of a CPU, or one CPU, you need so much of memory. There's no such hard and fast rule. Okay, it again depends upon the kind of applications. Don't worry, we'll talk about all this in our course when we come to Azure virtual machines.
Got it. Thank you, Kiran.
Okay,
Yeah.
Manda.
Hmm. Go on,
So,
please.
talking about the instances, CPU, RAM, etc. But there is something like a serverless computing where Lambda functions can be written.
Yeah,
Uh,
yeah, we'll talk about that as well.
okay, that if you're covering, that's fine. And one more thing, will you be covering the Kubernetes setup and its essential concepts in this course?
Wait, let me come to that point. Okay.
Okay. And yeah, and one more thing, in terms of the number of instances or RAM, CPU, the choosing, I think we should do the TPS measure of a web application or a web service, and accordingly we should choose the right amount of number of cores and the RAM. So
Yes.
could you please cover it up a bit on that, rather than
Yeah.
directly choosing the 2 cores 4 GB RAM directly like that? If somebody was asking me, give me the mathematical, the computation that on 1 million users, with maybe a 20 TPS, uh, the throughput, how many
Mhm.
cores, how much RAM, and those things, maybe that sort of a derivation would be really helpful in terms of
Yeah.
measuring
Yeah,
if
that
you're
would be
covering
really
the.
helpful. Sorry to interrupt you. Uh, that would be really helpful, but I'm not a performance testing person.
Okay. No, no. In terms of infra, the estimation and all, it is essentially needed because, let's say when we're talking about, okay, we are supporting maybe 10 million users with a throughput of 20 TPS, and
Mhm.
we would essentially need this much of infra, this much of replication, this much of maybe we need to host it in different data centers. These kind of the estimates are essential to be presented. So without a right justification, the finance team definitely will not approve. So that sort of derivation, if it has been covered as part of this course, that will be helpful.
Okay. So let me tell you, when there are already different instance sizes based on the use cases. Okay. When we learn about Azure virtual machines, we learn about that. So uh, it kind of lists on certain, I mean, for example, if you're running for databases, it will, Azure will suggest that use these kind of resources. Okay. If you're using, let's say, if you're using for machine learning computing, Azure will suggest that these are the suitable models. Okay, and the benchmarking happens later. First you create your virtual machines, then you do the benchmarking. Yes, you're right. If you're a very large organization, let's say, a global organization like a JPMC or a Citibank or or even Samsung or Nokia, you will have what we call as a performance testing team. Okay, what does the performance testing do is what you suggested. They will run the benchmarks. There is something called as load testing, okay, which they run, like what happens if 1,000 concurrent users are accessing my website at the same time in this given capacity. What happens if 10,000 users are accessing at the same time with this capacity? So those are the people who are going to draw the benchmarks. uh, as I said, I have not worked in a performance testing team, and I haven't run any load balancing load tests. But what we do is basically do a benchmarking. So you anticipate your load initially, and you create some virtual machines, and there are a lot of there are a lot of scaling options. Okay, for example, cloud takes away all this pain by using something called as auto scaling. Okay, so what does auto scaling mean? So I'll give you a 2 minutes brief and then we'll move on.
Yeah,
So in case
actually,
of auto scaling,
sorry for
let's
interruption.
say, mhm.
Yeah, so I think auto scaling based on the CPU load or RAM utilization, it tries to replicate the other instances. That's fine, but I was hard finding to convince the finance team to get the infra approvals without a proper estimation. That's why I was asking for that. Sorry if it is more elaborate. Maybe you can cover it up later. Yeah,
Yeah,
please go
so
ahead.
as I said, yeah, just for the others information also. So cloud mostly covers auto scaling, which will infinitely, or rather not infinitely, it will scale up to a certain limits. For example, you started your application with two VMs with a certain size. Okay, let's say 4 GB RAM and two cores of CPU. Okay, so you can configure in such a way that if the CPU percentage increases to above 80%, the average CPU of these two machines goes above 80%, then you can configure in such a way that a new VM is automatically added. Okay, so let's say you have two VMs and the CPU utilization has gone above 80% on both the machines. That means more and more people are accessing your application. Okay, so now it automatically scales up to the next machine, three VMs with the same size, of course. So earlier you had 8 GB and 4 cores of total capacity, though you don't measure like that, but yeah. Now you have the same thing 3 times. That means your load also comes down to, let's say, 65% or something. Okay, but even after adding another VM, the load after a certain time went up to again, like say 82%, the average CPU utilization. Then your auto scaling option in the cloud, okay, um, notices that even if it needs one more machine, sorry, it increases the number of VMs to 4. Okay, so you can also set the upper limit till how many VMs you want it to increase. Okay, now it let's say it came back to 52%. After a certain time, let's say there is less CPU, less number of people coming up. Maybe it's after hours, midnight in your particular country where it is popular. Then maybe the your 4 VMs is not really, because the CPU utilization is only, let's say, 20% on an average on each VM, on each virtual machine. Then your cloud, you can set another rule stating that whenever the average CPU utilization is greater than 20, less than 20%, scale down, decrease one VM. Okay, so now the CPU utilization may be about 45% or something. Okay, if it's further continues to go down, even after 3 VMs, the CPU utilization has come down to till 20%, because more and more people went to sleep. Maybe it's your internal application, it's the end of the shift. Okay, then it will decrease up to 2 VMs. It's not recommended to go beyond 2 VMs. Okay, you need at least at any given time 2 VMs. So you can also scale it up to, you can set a number, I want to scale up to 55 machines. Okay, so a lot of those questions that someone has asked right now will be addressed by this. But if you're looking specifically for benchmarking, okay, if you're specifically looking for, to understand how the system behaves for a certain number of instances, the answer is tools like Load Runner, which is a performance-based tool, a performance monitoring tool, which will give you the accurate number of, the accurate observation. All right. Okay. Anyway, we are wasting, not wasting. We are spending a lot of time here. Let's move on because we have a lot more to cover. So coming back to Azure, what is Azure? Azure is Microsoft's cloud offering. Oh, okay, yeah. One other thing I wanted to talk about, like someone has pointed out, we have three types of cloud services. Okay, IaaS or infrastructure as a service. Okay, this is the predominantly used one, but also there are other ones like PaaS, platform as a service, and then there is SaaS. Okay, software as a service. So what is infrastructure as a service? So let's say you are a big organization. You want to move your workloads to cloud. You don't want to take the headache of maintaining the underlying infrastructure, the data centers, the physical servers and all. But yeah, you want to make sure you run your own version of operating system. You want to maintain everything yourself. So this is where you get the virtual networks and the virtual machines for hire from cloud providers. Okay, you can rent them and start using them. Whereas platform as service is slightly different. Here you are a developer and you don't want the headache of maintaining the operating system. You don't want the headache of maintaining the Java runtime. For example, if you're building a Java application, you need to first have a server or a virtual machine or a physical machine. On top of it, there will be an OS. Okay. On top of it, you need to install Java runtime environment for your Java application to run. So all these underlying things will be taken care by cloud provider. You just need to plug in your code, update your code into this platform. It will work. So some of the examples, has someone suggested, Lambda is one of the serverless things. You have Azure App Functions in Azure. Okay. You have Azure Web Functions, which is also similar to that. Okay. These are serverless components where here in IaaS, okay, there is the physical server. Sorry, the physical server. On top of it, there is OS. And on top of, I mean, just talking from a simple virtual machine perspective, on top of it, you have runtime environments. Like I said, if you're using a Java application, you need to have Java installed on it. If you have Python, you need to have Python installed and all the other modules. Okay, so here in this case, only the physical layer is taken care by the data center. Of course, OS is also provided by the cloud provider, but for any upgrades or anything, you have to be responsible. And also you have to be responsible for the runtime. You have to configure your Java or Python or whatever it is. And on top of it, you maintain the code. So you're responsible for these three things. Okay. Whereas in platform as a service, okay, you're not responsible for any of the three things. You're only responsible for your code. So you have to just write the code and upload in your cloud service, and it will take care of running the application. Okay. In terms of SaaS, it's slightly different. Okay. SaaS is the prime example for SaaS is like your Google Drive, right? When you use have you ever written code for Google Drive? No. Have you ever maintained a server for Google Drive? No. Everything is maintained by Google. All that you need to do is log into drive.google.com, create an account for yourself if you don't have one, and start using it. Not only that, let's say you are a large organization like an auditing company, let's say KPMG or PricewaterhouseCoopers, any of these companies, and your main skill is auditing and financial services, but your teams need learning platform to learn new things about various taxation, various auditing rules and all these things. And also they need to learn on some internal guidelines like, let's say, workplace ethics and all these things, conflict of interest. So you need to put all of them in a learning platform. So you can do one thing, you can put a team and say that develop a application. You can hire a development team to develop a learning platform and create your own learning platform, or you can use an existing service like LinkedIn Learning. Okay, LinkedIn has a learning platform, right? Or Pluralsight or Udemy, and say that, hey, I want to host my learning sites, I want to use your learning platform, and also I will have to host some of my courses also. Is it possible? Udemy says, yes, of course. We will give you an admin account. You just need to give access to those people who will need access to your learning platform. Maybe you can integrate your Active Directory so that they will authenticate automatically. And you could also create your own custom courses apart from the catalog we are offering. So Udemy has a lot of courses. So JPMC can use all those courses, or sorry, KPMG or PricewaterhouseCoopers, and also they can upload their own courses created by their learning team. So they don't have to maintain either infrastructure or code or anything. They just are responsible for the content which is created above these things, right? So content and administration is only responsibility when you're using a SaaS application. That's the difference. So as I said, the examples, there are a lot of examples these days. Okay, you might have heard about your payroll might have also been a SaaS application. Like if you're using anything like Hevit or Workday, this means your company has your company is not hosting that infrastructure. Your company is not maintaining the code. It has given it to someone else, and they are running the code and runtime and everything. But only your team is responsible for content and administration, like who should be given access, what level of access should be given. Only these things will be given. So these are three types of cloud services you have. Okay, infrastructure as a service, platform as a service, and software as a service. Of course, in our course, because and as you go down, the amount of uh, management decreases. Here, you will have to maintain a lot of things like your OS, your runtime, and code. In this case, only the coding, you have to be responsible for coding and processes like CI/CD, continuous improvement, continuous integration, and delivery. Here, in this case, there's no, I mean, from the application perspective, there is no responsibility. Only the content management is your responsibility. Okay, so the management, that is the advantage. You will spend less time in managing a SaaS application than you do in a IaaS, meaning you need more people to do this as well. So most of the DevOps work is also focused on these services. Okay, so we are going to focus on IaaS services which are available on Azure for our course. Maybe we'll touch one or two services on platform as a service, but mostly focused here. Okay. All right, let's move on. So as you know, Azure is Microsoft's cloud offering. It's one of the leading cloud providers, only behind AWS in market share and service offerings. So if you look at the number of services or the amount of customers, so AWS is the clear leader, obviously, because they've started much earlier. They've started in 2006. Azure was started in 2010, but it took a time to take off. There were a lot of changes and all these things. But yeah, it's the second most used cloud after AWS. Azure's services span various areas from virtual machines, storage, machine learning, IoT, big data, and security, and many more. Okay, most of these are again PaaS and SaaS applications. Uh, yeah, so they have a lot of services in Azure. Okay, so if you look at Azure, as I said, any cloud.
Kiran, we can't hear you.
There's a lot of noise actually. We hear some air sound, that's all.
Hello. Okay.
Kiran. Yes, we
We are
can hear
able to
you.
hear now. Thank
Yes,
you.
Kiran, we are with you. We can hear
Do you
you.
do you still have the noise?
No,
It's
clear
better
now.
now. It's
It's
clear. Yeah.
better.
Yeah. I'm not sure what happened. Mhm. Yeah. Someone still not. Vinay, are you still not able to hear me? All right. I think a lot of you, many of you have confirmed. So let's move on. In the interest of time. All right. So this is this is the Azure infrastructure. So underlying any cloud, it's nothing but a group of data centers spread across the globe. All right. So similarly, Azure's infrastructure is also spread across the globe. These are the various places which Azure calls as a region. A region is a group of availability zones. Okay. An availability zone is a collection of data centers in close proximity, meaning in one big data center complex, you have a you call it as a availability zone. And within one region, you might have two or more availability zones, or sometimes only one availability zone. What do I mean by an availability zone? As I said, it's a collection of data centers. Okay, one or more physical data centers in close proximity is known as a availability zone. So when Azure starts any new region, for example, let's say they start a region in Hyderabad. I think they have one. Where exactly in South India, I don't know. But let's say they started in Hyderabad. Okay, Amazon is going to start their data center in Hyderabad very soon. But suppose they also start it in Hyderabad. So the way they do it, they will create a data center complex, meaning one or two data centers in Uppal. Okay, I think most of you are aware of Hyderabad's topology, and they might create another one in somewhere far off from Uppal, like Medchal. And if they creating another availability zone, they might create something in Patancheru. They will create in different locations, so that even if there is some kind of some kind of what you can say, disturbance in one of the areas due to floods or whatever, the other data centers are still working. Okay, so within a region, it will give you high availability. All right, so these are the available regions as of now. Azure says they have about 160 data centers in various regions. Earlier, they used to publish the number of regions, which they said about 60. Okay, as you can see, obviously, most of the data centers are are placed in US, obviously, because there's a lot of demand from the US, and many in the Europe also. Um, so some of these dotted ones are announced reasons which are going to come soon. Okay, so yeah, these are the various amount of data centers that Azure has globally. We are not sure if Azure uses only for the Azure public cloud or maybe Office 365 and other services as well. But yeah, this is what they put in there. This is from their official website, of course. Okay. Moving on to the very important thing, DevOps. So what? Let's understand what
Thank you. I mean, very good explanation. When disaster happens, one side goes
Mhm,
down.
mhm,
So it shifted to the other server, right?
mhm.
Other region. I mean to say,
Yeah, yeah.
you said one word, high availability. Can you just
Mhm.
brief us a minute about high availability?
Okay, so as the word says, availability. What is availability? That means your application should be available. High availability means your application should be available for more than, I mean, you can define your own agreements, service level agreements, or you can define your own benchmarks. Okay, but generally it is measured in the terms of like 99.95% or 99.98% of availability. So that means in a month, you cannot have a downtime for more than 1 hour or 50 minutes, something like that. Okay, so that is your high availability. High availability means your application is available throughout the year 24/7. Okay, even when there is high load and all these things. Even if there is a downtime, you have to make sure you fix it very soon. And when I say high availability, I'm talking about high availability of the infrastructure, and there is high availability of the application. Okay, in IT world, it is always a given that your systems will go down. Various reasons. Okay, sometimes it's software, sometimes it's network, sometimes it's hardware. Okay, you cannot even say what happened. I mean, there will be a root cause, of course, but immediately you cannot pinpoint. So that's why when you talk about high availability of the applications, you have to create your uh, that's why you need to have redundant systems, meaning more than one system doing the same thing, which is again load balanced, so that even if one of the machines, one of the virtual machines goes down, for instance, your traffic is routed to the other virtual machine, which might be located in a different availability zone, okay, or a different region also sometimes, but that's for very highly mission critical applications. And Azure also gives you some SLA saying that if you are using these kind of services in these locations, you will have this much of availability. That's called service level agreement. We'll talk all about that later, but high availability is the concept that your systems are available most of the time, okay, in terms of like 99.9% of time or more than that.
Okay, it's kind of no active or active standby kind of in two regions while load
Yes,
balancing
sometimes.
between.
Yeah, sometimes you might create two regions. In that case, you might have active setup, but mostly, unless it's a very mission critical application, creating within the same region in different availability zones. So within a region, you have availability zones. Again, as I said, they will be separated from some distance. So so you'll still get the high availability even if you're putting it in different availability zones in the same region. Okay, if you're talking about cross region uh, thing, then you're talking about DR scenario. High availability is slightly different from DR. Okay, DR is where your entire application crashes down, entire region crashes down, then you have to shift your load to a different region altogether. Okay, so these two are different strategies. High availability is very common. I mean, it has to be built in for every application. DR should also be built in for all applications, but that's a different approach. Okay, we'll talk about that later. All right, DevOps. So DevOps has been the buzzword in the market. Okay, and you've been hearing this from like last five years at least, and more people are talking about it. So what's it's all about? Okay, so this is the Wikipedia standard definition. DevOps is a set of software development practices that combine software development and IT operations to shorten the system's development lifecycle while delivering features, fixes, and updates frequently in close alignment with business objectives. What does that mean? That means it's about set of practices that software development teams follow to make sure your software is released faster to the market, and not only the initial release, but any new features you add or any bug fixes you have to do. Okay, let's say you launched a superb application, but people are people are seeing a lot of bugs, okay, a lot of issues with your application, then you should be able to fix them very soon as well. Otherwise, user base will shift on to your competition. Okay, and these fixes and updates, of course, should be in close alignment with your business objectives. What is your business objective when your business team wants to create this application? Okay, so that has to be kept in mind. So DevOps is set of practices. Okay, it's about how you do software development rather than what you do. Okay, so it's about bringing development, QA, and operations teams together to work as one unit. Earlier, when we did not have this culture of DevOps, so what used to happen is development team, is the team is the one that writes code and tests locally on their machines. Then QA team will test some of the code part or maybe directly the application. So let's talk about development team developing a code, writing some code for an application, let's say a Java application, and they give it over to operations team. Okay, so we have tested in our local machines. You just deploy it in the servers. But let's say the application was started on Jan 1st, 2021, and the uh, go live is in April 1st. Okay, so till March 30th or till March 15th, operations team would not even know the development team is working on some project without the DevOps practice I'm talking about. Okay, when the DevOps practice was not in place, that was the scenario. So with 15 days to go for the release, development would throw the code over the wall. That's what the term they use. So they would simply throw the code over the wall to operations team and say, you take care of it. Now operations team is caught off guard. They are told that they have 15 days to provision the infrastructure, deploy the code, configure whatever configuration has to be done, and now um, they're in a tight position. They deploy the code, it stops failing. Okay, and they say to dev team that okay, your code is not working, and the dev teams typically come with the response, it works on my machine. It's your problem. So now I have to figure out what is the difference between his machine and my machine, and fix those issues. And within the 15 days I have to fix a lot of issues and be ready. That means delayed timelines, and um, or bad quality software being released. All these were issues. But today, with DevOps practice, what it suggests, what DevOps recommends is that from day zero, that means first day of your software development process, you have to bring all these teams together: development team, QA team, and operations team. All three of them should know that you know we are going to we are working on a so and so project which is working on so and so platform. And you also, now earlier there used to be application architect, now you also have cloud architect or infra architect, who also talks to application architect and understands which is the best place to host the application, whether to choose an IaaS service or a SaaS service, no, not SaaS, sorry, or a PaaS service. What would suit best, or a combination of these two things. Sometimes you might use virtual machines with managed databases. Managed databases are again like PaaS solutions. You don't have to worry about underlying OS. Okay, so these two architects and the teams also sit together and understand what's the best approach. And from day zero, they start working together. So it means smoother releases, faster releases, and also later, you can, apply these things incrementally for more and more updates. Okay, so you might have also heard about Agile. Agile and DevOps work in close, close coordination. Agile is about releasing software faster and iterating over it. For example, what does it mean? So WhatsApp has launched in 2011, 2012, around that time, right? So at that time, um, did you have the voice feature, voice calling, or did you have the status, what we call stories or status these days? Or did we have even image sharing was not there, I guess. Initially it was only a texting platform, right? But incrementally they have added all these features. Suppose WhatsApp has waited for 6 years to develop all the features and release one big bang with all the features like status, stories, and all these things. What would have happened? It would not have become so popular, because by that time Telegram or any other uh, any other application would have overtaken. Even Facebook Messenger would have overtaken. Then WhatsApp was not part of Facebook, right? But they have launched an application, minimum viable product, which works for the basic thing it is doing, which is texting. Later they started on adding incremental features. They've added later they've added voice messages. Later they have added voice calling, then video calling, then statuses, then now WhatsApp for business, whatnot. Okay, they have added everything now. Okay, but still don't use WhatsApp, use Signal. Okay, yeah, just giving an example. So that's what we call an agile process, where you don't wait for so many years and create a big bang application, but create a minimum viable product and keep on iterating over it, making more changes to it in regular intervals, so that you can test each feature carefully. And you could also have good scope to increase and keep the user base also. All right, so that's agile process, and agile and DevOps work together. Okay, so what is the recommendation? So DevOps is all about working culture. How do you work together? All right. But DevOps is all about all these things as well, which I'll come to in a minute. But if you look at a detailed view of DevOps, what is it? What it is a culture that aims to create better coordination between development, QA, and operations. The same thing I talked to you about, talked to you in a few minutes ago. And what it's not a single technology or a tool. DevOps is not like, a Java or Selenium or VMware ESX or, Microsoft Microsoft, Dynamics CRM or SAP or SAP. It's not like that. It's a culture. It's a set of practices. Okay. But what is the objective of DevOps? Again, as I said, to build and release software quickly and maintain applications with high availability and resilience. What is high availability? We already talked about. Resilience is the ability to recover from failure. So if there is a, as I told you, in IT world, failures are expected. You can expect failures all the time. But resilience is all about getting back on track. Okay, immediately after the failure. I mean, immediately in the sense in a few minutes or whatever time it takes. And some of the similar roles to DevOps. Okay, technically speaking, DevOps is not a job role like a developer or a QA engineer. You cannot say DevOps engineer in a theoretical sense. Strict theoretical terms, that's not possible. But of course, we have job roles called as DevOps engineer these days. Okay. So Google says DevOps is a practice and SRE is the role which enforces DevOps culture across the organization. Okay. So SRE means site reliability engineer. But there could be slight difference between SRE and DevOps. Okay, SRE is more about maintaining the production applications and monitoring observability and all. DevOps is all about making this pipelines and making the development faster. Okay, but these are like what you call overlapping roles. Some organizations might call their team as SRE team, but they might be doing what we call as a DevOps job as well as SRE job. Some organizations might have a separate DevOps team and a separate SRE team. Some organizations might call their team as a DevOps team, but they might be doing more of site reliability engineering. Okay, so there are no clear-cut distinctions. Okay, and also you will see a lot of jobs which will say DevOps engineer and a lot of jobs that say SRE engineers. Okay, there are a lot of overlappings, but emphasis is different on both these roles. Very thin line of difference. Then you have cloud operations, which is again like DevOps, where you do a lot of automation, but maybe not much on the application integration and all those things, maybe more on infrastructure side. Okay, that's the cloud ops part. All right, so I told you DevOps is a practice. So are we going to talk theoretical terms in our courses? No. So DevOps suggests these things. You have to build your applications quickly and build and release software quickly. So how do we do this? Simply by establishing good processes, by saying that you should be friendly with dev team, you should talk to dev team every day, you should attend stand-up calls. Simply by saying these things, you cannot achieve these things. You need tools also that will help you perform these things faster and faster. Okay, so that's why you would need a DevOps team which knows a set of tools, okay, to help you build and release software faster and also maintain the applications with high availability. Okay, so what are those tools we are going to see, because we are going to learn about those tools only in our course. Okay, any questions on this part? So in simple terms, I would say DevOps is process or practices, as you can call it, plus people with the right mindset and of course right skill set and tool set. You need to have a tool set to achieve what you wanted to achieve. When I say tool set, it's the tooling that you use to automate many of the things we talked about. How do you make sure the code that is written by developer is fastly deployed or fastly built into a deployable unit? Okay, for example, if your developers are working on Android applications, how do you make sure you quickly convert that into an APK and release it into your dev servers and test it before you release it to your production servers? Okay, all of these things are um, tool set which will help us achieve these things. Okay, so let's see what are the various processes that a typical DevOps engineer might see in a day-to-day life, not a day-to-day life but in their job role. Okay, so first thing, hello, am I still audible? Just a mic check.
Yeah.
Yes, correct.
Okay, thank you. All right, so first, to build your application you would need the infrastructure. Okay, it could be on your on-premise in the sense your own data centers, or it could be on cloud. But first thing you need to do is you need to build your infrastructure, right? So first process is building your infrastructure. The second process is, once you have your operating systems, let's say virtual machines with operating systems already there, then you need to configure them to run your applications. For example, your development team says we are building a Python application. So on top of you have your virtual machines or physical machines. On top of it, you have your operating systems, maybe CentOS, maybe Ubuntu, maybe Red Hat Enterprise Linux, or maybe Windows. So on top of it, you need to make sure you have the runtime environments like Python and all the required modules for Python and any security hardening. Okay, you have to make sure the server is secure and hackers cannot easily access it. Okay, and also you have to configure all these things. and maybe some load balancers or whatever you have to do. That's also partly part of your building processes, including your load balancers also. Then you have to compile the code that is built by your developer. Your developer writes code, but for the code to be deployed onto your servers, it has to be in a certain format. Okay, or multiple developers work on the code and they share it in a central repository. Then you have to check if the code altogether is working or not. Okay, so that process is called as continuous integration. Okay, so we have this process of continuous integration where you continuously take the code once the developer checks into a source code repository. When I say source code repository, it's like a location where developers store their code. The next section is to automatically deploy this built code into your servers. So that's called as continuous delivery. So once you release the software, it goes live, then you start monitoring the application. All right, you have to see if it is running all the time, if there are any errors. So monitoring is also combined with what we call as alerting. Alerting is whenever some application goes down, you should get a call or an SMS or an email stating that so and so application is not working. You go and troubleshoot. Okay, these are the main, I mean, at a very high level, these are the various levels you have. So you have building process, you have configuration, you have CI and CD, continuous integration and continuous delivery, and you have monitoring and you have alerting. Okay, and I already told, right, your developers check in your code into a source code repository. So you have to maintain a repository where your code is stored, where your automation scripts, everything is stored, and that part is called as your source code management. Okay, so these are the some of the very commonly used tools in a DevOps setup. Okay, but again, where do you run all these things? Even if you have to build your infrastructure, you need some automation and you need some uh, e- so let's say you are a large organization, every 10 days or 15 days you might have to build new infrastructure on cloud. So you need some automation. You cannot always do it manually through the website. You need automation. All right, so for that we have Terraform. Okay, which is an IAC tool or infrastructure as code, where you write scripts and they will deploy the infrastructure for you. Okay, it can be used on Azure, it can be used on AWS as well. Of course, Azure has its own templates called as ARM templates, but that's not very effective when compared to Terraform. Okay, so in our course we are going to learn about Terraform. And configuration, how do you automate tens of, so for an application, let's say you have three different environments: dev, staging, and production. And in each environment, let's say you have four servers for web, four servers for web, for DB, and four servers for some other application or something, middleware. Okay, so if you have to run configuration on each of these machines manually, it's going to take a lot of time. So you need an automation tool for software configuration, and for that we have Ansible. Okay, and for CI/CD, to take your code and deploy it into your servers, you have Azure DevOps. Of course, there are a lot of other tools, but I'm talking only about those tools where we are focusing in our course. For monitoring and alerting, we have Azure Monitor, which is a Azure service. Okay, and of course, when it comes to monitoring, I'll also talk about a lot of things which impact your monitoring. How is your team performance measured? What are the metrics? All this theoretical part also is also there. And for source code management, we talk about Git, which is the software, and we talk about GitHub, which is the repository where you store the code. All right, and of course all of these things have to be done on our platform, not just the virtual machine. On top of the virtual machine, you have an operating system. So a lot of these operations are done either on your machine or in a virtual machine. So which runs what is there on your computer? What's the thing that runs your computer? So when you start your computer, what is the one that comes up?
Operating system.
Exactly. So you will also have to learn about operating system. All right, so we'll learn about Linux as well, because Linux is the key part that is driving development of Ansible, okay, or even Docker. I did not put Docker because it's part of your infrastructure only, but yeah, I should have put Docker somewhere. So we are going to learn Docker also. Okay, so these are the various tools we are going to learn along with our operating system, which we are going to learn about Linux. All right. We are not going to do anything with Windows because Windows is not predominantly used in enterprise servers. Linux is mostly used. Okay. But yeah, you can get the drift of Windows also.
Will
So
you
that's
be
what we are going
covering
to cover.
will you be covering the Kubernetes as well for the containerization and orchestration?
Yeah, let me come to that. Yeah, someone has already asked me. Okay.
Kiran,
So at a
what is the tool for monitoring and alerting?
that's Azure Monitor, which is an Azure inbuilt monitoring tool.
Okay, thank you.
Yeah, the name itself is called as Monitor, Azure Monitor. Okay.
Okay.
Yeah, we are not touching any third-party applications. Maybe you can learn them later. All right. So this is in a nutshell. But yeah, I wanted to show you the flow and what tools we are using at each level to give you an overall understanding. All right. I know it looks like very overwhelming. Yeah, this course is a little, jam-packed one, and people are even asking about Kubernetes. So yeah, but we will cover from ground zero to and go up. We'll start from Linux, and we'll talk even before we talk about Linux. We talk about IT infrastructure and virtualization and networking concepts. All these things are there. Okay. Okay. So let me. I mean,
So
yeah.
virtual
So
will be covering in terms of hypervisor configuration as well, like
oh no, no. Why do you need hypervisor configuration when you're using cloud?
because some of the solutions which requires an additional software to be connected to the virtual machines over PCSE interface. So,
No,
for
no.
example, yeah, so in those contexts, because not everything can be independently hosted, right? Some of the times we need to connect HSMs or some additional cryptographic hardware or some anything could be possible to connect to the over USB interface, right? While we are developing in-house, same thing can be done via cloud as well. So at that time, the hypervisor configuration is essential. So when you say virtualization, will you be covering that?
No, no, I'm not even covering virtualization. Let me take the sentence back. I'm talking about virtualization as a theoretical part, okay? Because that's not part of the course, okay? We are not going that path. We are only talking about the infrastructure as a services. So we are forgetting about the underlying infrastructure because we are giving it up to cloud. Cloud will maintain that. That is already abstracted from me.
Okay.
Yeah. All right. So if you look at the DevOps as a, as a building, from my point of view, this is how it stands. Okay, you need infrastructure, the base infrastructure, which includes your virtual machines, and the pass providers. Sometimes you need a managed database, and you would need containers also comes in that part only. Then all of these things, including because everything we are writing as code, including your CI/CD pipelines, everything is in part of code. Okay. So those have to be maintained as part of your source code management along with your application code also. So this is
Kiran, you were saying code. So what type of programming knowledge required?
yeah, I'll talk about that. Okay. So the main thing that holds all these things is automation. That the main thing that holds all these things is automation. That makes our DevOps building. Okay. I'm sorry, folks. I'm running little late on time because I have a office call at 9 o'clock. I know today is Saturday, but I have an office call today. So let me quickly wrap through what we are going to cover in our course. Okay, we are talking about operating system. As I said, we will talk about GNU Linux. Linux operating system. What is the file system? The navigation. What are the editors? The package, process, and service management in Linux. Okay. Then we talk about Azure, of course. How do you manage the Azure account? What are resource groups, identity and access management, virtual networks, virtual machines, storage, DNS, and automation Azure CLI. And scripting, we'll talk about Bash, which is a Linux shell scripting. Okay, what is the structure, conditionals, and all these things. And as it said, for building your infrastructure, we need an automation. We need automation, and we are using Terraform we're learning Terraform, and using Terraform, we'll build our applications. Source code management, Git and GitHub. Okay, and the various things we are going to learn about them, how to install Git, how to configure your GitHub, all these things. Then we are going to, in software configuration management, we are learning Ansible, how to install Ansible, configure, what are ad hoc commands, what is a module, what is a playbook, variable, inventory, and all these things. And CI/CD, we are using Azure Devops, which is a Microsoft service again. So we'll talk about what is CI/CD, the overview of Azure DevOps, what is an agent, integrations, and all these things. In containers, we're talking about Docker, how to install, how to configure, how to create containers, how to build images, how to how to create your own volumes, where do you store these images, Docker file, and of course Kubernetes. But I put Kubernetes in lowercase because Kubernetes in itself is a very big course. Okay. Uh, so you have to start, you have to have at least 2 weeks at the minimum after completing all the above. Of course, to learn Kubernetes, Docker is a prerequisite. To learn Docker, Linux is a prerequisite. Okay, so if anyone asks me for advice on learning Kubernetes, even in my organization or outside, I say start with Linux. Okay, so we are laying the strong foundation for understanding Kubernetes, but we are covering Kubernetes at a very high level. We are understand. I mean, I will create a cluster and show how it works. I will also deploy one application and show how it works. But it's a one-day session, one session, which is going to be a very high-level session. We're not going into in depth of Kubernetes because, as I said, it itself may take uh, more than 2 weeks. All right, at least 2 weeks for me. Okay. So we will cover Docker, but not much on the Kubernetes side. And as I said, from the monitoring and alerting side, we'll cover Azure Monitor. Okay, I'm sure you might have a lot of questions. So we'll wait for that, but let me complete the slide. Okay, so again, this is based on some of the frequently asked questions. What should you have to join this course? Okay, so you need a computer, obviously, with 4 GB RAM, and minimum of i3 or quad core would be fine. Okay, otherwise it will frustrate you to I mean, the slowness will frustrate you. And system admin rights, of course you need system admin rights because you need to install some software which I listed below, like git bash, which is a git tool, as well as which will help you to access your virtual machines. And to write code, you need VS Code, which is optional but good to have. Azure CLI is another software which you could install on your own machine, or you could use on virtual machines also, but I recommend installing on your local machines or your laptops. And subscriptions, what subscriptions do you need? You can go for Azure free tier subscription. Please don't create it before I tell it to you, because it's only valid for 1 month and you will need a credit card for sure. It doesn't accept debit card, unfortunately. So you would need a credit card. Bad thing. Okay, that's one thing. And second thing is, it is valid for only 1 month. Our course can go up to 8 to 10 weeks at the minimum. Okay, so you will need a backup account, another free tier account. But the thing I observed is Microsoft is not allowing you to create uh, secondary accounts easily. Okay, it will it's going to block your IP address or doing some something in the back end. A lot of my students have complained that once they created the one free tier account, they're not able to create with another email address or another credit card. So you might have to ask your friends to help you create a secondary account. Of course, that's after 1 month of our course. And then what are the other services where you need to log in or you create an account for? For example, GitHub, Azure DevOps, these are all free services. Docker Hub, where you store your Docker images. Freenom is a free DNS where you can buy your own website names, not, I mean, whatever website names are available. That will help you understand the DNS part, which is optional again. Okay, software, I told you, you need those three things. From a personal perspective, what do you need? You don't have to have anything. You just need good appetite for learning. Okay, the hunger for learning, and quality time for the classes and practice. Why did I highlight quality time? Because you might join, but if you're joining on your iPad or phone and lying on your couch, you might as well fall asleep. Not that my classes are boring, but if you join from a computer and stay attentive and ask me questions, that's what I mean by quality time. And active participation, that's the same thing. Participate in the classes, in the quizzes, in the, in the follow-up exercises. That will help you. Skills. Earlier, I used to say that it would be good if you have Linux or any programming knowledge. That would be an advantage, but people would be discouraged. That's why I said no prerequisites. You need not have any coding experience, but if you're good with Linux or any programming language, that would be definitely a big plus for you. Otherwise also it's fine, because we're going to start from scratch, and you need to pay some additional effort of you need to spend some additional time in covering up the basics. But yeah, that's fine. You if you're joining this course, that means you're interested in you know building your skills, so I'm sure you'll spend that additional time to learn those skills. But no hindrances, no prerequisites for starting this course. Okay, that's the FAQs. That's the FAQs part. uh, yeah, another FAQ
Usual,
is like,
Kiran,
how long
usually
this course lasts.
which
Yeah,
coding
just give me
language
2 minutes.
uses for most of?
Just give me 2 minutes. Just give me 2 minutes. Okay. Um, so as I said, yeah, this course will take about 8 to 10 weeks. Okay, Friday through Monday through Friday, no Saturday Sunday classes, except in rare cases where so the times are bad. I have fallen ill many times due to COVID sometimes, and some other things also. But yeah, it might extend sometimes. So sometimes we might have to do a weekend classes, but very rarely. Okay, not very often. Um, that's another question. Do I give resumes? No, hold on, please. Okay, let me complete. So the other question I get is, do I give you resumes and all these things? No, I don't give you. Do I do job support? No, I don't do. Okay, but I can help you in building your resume. If you can share your resume in one of the classes after the class, maybe I'll help you say where you can tweak it and all that. Okay, yeah. Now you go on.
How many number of services of Azure will be covered? Because some of them are paid, so we cannot try it out with Twitter account. But
No,
at least to familiar, do you
no, no,
show some site?
no. There are Azure free tier is a little different. I'm not sure who this is, because I'm not able to see the other screen.
This is Durga.
Azure services are free for 1 month. Uh, they give you 13,000 worth of for a month. Okay, so based on how you are using, you can use any service, but there might be some service limits, like you cannot create more than 4 virtual machines in the same at the same time. Okay, there might be some service restrictions on free tier account, but you can almost all explore all the services. And for the services we are talking about, because we are not creating any high level machine learning platforms, right? We are not creating big clusters. So we are talking about virtual machines, virtual networks, and storage, like block storage and disks and Azure files. So all these are covered in your free tier, so you need not worry about it. So only thing you need to focus on is not focus to take care of is the secondary account after your first free tier is over.
Will it cover? I mean, because mostly from the certification point of view, we
Mm-hmm.
should know the latest services and the almost all the essential services to crack the certification. So in that perspective, I was looking at.
Yeah.
So if you
So sure,
if
you're
you
right.
can cover the at least the fundamentals at the high level and the most of the essential services, we should get some confidence to attempt the certification. That's the purpose.
Yeah, I understand your question, but this is not an exclusive Azure course. This is more of DevOps and Azure. Right. So we are going to cover key services, lot of the ground we are covering, but other services overview, I would suggest that you follow it up after this course. Okay. This is more like making you ready for a DevOps role rather than just for Azure role. Okay. You could see the breadth of the applications we are covering, right? So that means I will not be able to provide an overview of all the other services, but you could once our course is over, once you get comfortable with each of these tools running on Azure, you could start learning about other technologies, and you could start working on them. Okay.
Okay.
Kiran, what type of coding knowledge required?
Sorry.
Coding skill required. What type of code, like Python
Oh,
or?
okay. Yeah, that's a good question. No, we will not do any Python scripting. We are going to use as I said, we're going to learn shell scripting only. Okay. and we will use some, not exactly coding languages, but Terraform has its own kind of language, which is called as HCL, HashiCorp configuration language. Then for Ansible and let's say Docker, also Docker files, or Dockerfile has its own language, which is very easy to understand. Ansible and Azure DevOps pipelines, all these things can be written in YAML. Even Kubernetes, even if you want to write Kubernetes objects, you will use YAML. So we will learn YAML, YAML. You might have heard about this. So a little bit of JSON, but not much, more of YAML. And Terraform has its own language, as I said, so it's Terraform only. Linux shell scripting, we'll do Linux shell scripting, which is Bash scripting, as it is called as. What else? Yeah, that's it. So YAML is again not a programming language. It's more like a configuration language.
As part of this course, we'll be doing VPN and then subnetting, then IP range creation, all those things will be covered
We are do
as part of.
just give me a second, folks. Someone is calling me. 1 second, okay. Hello, can you hear me?
Oh, yes, Kiran.
Yeah,
Can I
not
ask my
VPN.
question? Yeah.
We will cover VNet, virtual network subnetting. Yes, we will also talk about the theoretical aspects of how subnetting works, what is public IP, what is private IP. Okay. Yeah, we will talk about all these things. Not VPN.
Okay,
Yeah.
so because the gateway APIs also has to be built with the private subnetting. So is that being covered? Gateway APIs.
We are not covering VPN peerings or
Gateway APIs.
gateways. Yes.
Okay. Proxies setups.
Hi
No.
sir, I'm Ravi Kumar.
Yes, Ravi.
Sir, can you tell me the DevOps in sir? Actually, I'm searching for jobs, sir. These modules
Mhm.
on cloud technology. What is the relation between the cloud technology and the DevOps, sir?
Okay, so cloud is your platform, your infrastructure, where you're going to
Mm.
where you're going to deploy your applications. Okay, so as I said, DevOps is the
Mm.
practice which makes these things go faster. Okay, so if you want to deploy an application on cloud, if you use DevOps methodologies, DevOps practices, and DevOps tools, it becomes easier to deploy it on your cloud in a faster and consistent manner. Okay, for example, you might be a solutions provider, you are serving more than one client. Okay, every when you have multiple clients and each client has their own requirements, so using the DevOps tools, like some of the tools we discussed, if you automate these stuff, you can create infrastructure for multiple clients simultaneously. Okay. uh,
Okay, sir. Okay. Okay, sir.
yeah, and also
Okay,
with a
sir. Okay.
consistent, without any errors. So someone has asked, we are going to do AKS. Yes, we are going to do AKS. I mean, again, Kubernetes very top level, very high level, but we are going to create a
Mm.
AKS cluster. No
Mm.
configuration on Windows,
Mm.
because Ansible is more like suited towards I'm talking from the questions that are posted in the chat. Okay. um, so yeah, using Ansible,
Okay, sir.
we use configuration management only on Linux machines. You can practice on Windows, but it's a complex
Mm.
configuration. I tried it once, I can help you with that. Yeah.
Okay, sir. Can you give me any contact number, sir, regarding these cloud technologies and DevOps? I mean, I have the how to learn the basic knowledge regarding the software, sir.
Okay, see, there is a contact number for the career IT. You can contact us and we will give you the details. Okay. uh,
Mm. Okay,
I
sir.
posted those numbers again. Yeah. So we are going to start this batch most likely from Wednesday. Yeah, Wednesday only it will start. Okay.
Kiran, one last question from my side.
Okay, sir. Okay. Thank
It's
you,
a
sir.
minute.
Thank you.
Yeah, go on, Madhu, please.
Yeah, what are the typical roles and responsibilities at a high level as a DevOps engineer?
Yeah, I talked about that, right? So you have to build your infrastructure, automate the building of your infrastructure, or what we call provisioning your infrastructure. You have to do these system configurations. You have to update your servers or install patches. Ravi, could you go on mute, please? Yeah, thank you. So you could you have to configure your machines. You have to build CI/CD pipelines, which will be a very big part of your DevOps role. You have yeah you have to build CI/CD pipelines and sometimes monitoring, setting up monitoring and alerting and be on call. On call is any high priority issues, even when no one is in the team. I mean, when no one is working, you might have to wake up and troubleshoot on weekends or weekdays. On call is one of the DevOps responsibility. Not in all cases. Some DevOps teams don't have on call. Some DevOps teams do have on call. On call is, as I said, weekend and off time monitoring. um, and yeah, these are the tools I mean, these are the things we are responsible for. Provisioning infrastructure, meaning creating infrastructure, configuring the servers, or sometimes access management also. Sometimes there might be an additional team which does the access management. Sometimes DevOps team might also do access management. Okay. And let's say you are an matured IT organization. When I say matured IT organization, you already have a large organization um, which is working on on-premise infrastructure, uh, but now they are planning to move on to migrate to cloud some of their services. So now you will be part of that team, and you have to work on creating POCs, meaning whatever application is there on your on-premise, you'll try to create a copy of the same application on cloud on a smaller scale and see how it works. Okay. uh, and otherwise you might do some shift and lifting, meaning existing applications you will take it to uh, cloud and migrate there. All right. So, or you might already be on cloud, but your team wants to containerize your applications. They're running on virtual machines, but you want to use Docker or Kubernetes. Okay. Then you will work on the containerization part. All right. Or there is already DevOps practice. You need to maintain them because you keep on getting new requests for CI/CD pipelines, new requests for new infrastructure. So there is everything already configured. But as someone with all these skills, okay, you have to be ready to maintain these things and also upgrade them, or incrementally make improvements to existing process. There are various. I mean, depends upon the maturity of the organization, depends upon the where your organization is right now. Okay. There are no set of practices, but I said, you can go back to this slide always. These are some of the common things that you could think of. Or maintaining your source code repository, giving your developers access to them. Okay, let me take another question on the chat. This is Baramesh. How will be the job opportunities and what's the job assistance you will provide? How much experience we can put in our resume? Currently not working in any module and BTech pass out is 2006. Sorry, sir, I'm not going to give any experience. I mean, I cannot say what experience you can put, or I will not give any job assistance. Okay, that's not my part. I'm only a trainer. I will teach you, and I can tell you how you can be well prepared for the interviews, and based on your confidence levels, maybe I also have a assessment sheet which I'll share at the end of the course, where you can mark yourself currently. I mean, when I say currently, after the course, and maybe for the next 1 to 2 months, you will have to practice all these things consistently, because I'm going to teach all of them in a uh, structured manner. First I'll teach only Linux, then we'll go to the application installation, one part after the other. But once the course is over, you have to figure this together and continue practicing them, get more experience, hands-on experience, and read the blogs, listen to podcasts, watch YouTube videos, and based on that confidence you can apply to the job. So that's up to you. Okay. But I can give you assistance in terms of what kind of interview questions you might expect, or what kind of questions also you might get in certification exams like AZ900, but not job assistance, definitely not. And I cannot say what experience you can put. I will not, I'm not in that business. Yeah.
Kiran, one more last question here. See, I'm a 15 years experience as a test manager. I'm a test manager at this point of time.
Mhm.
So I want to switch over my career to as a test manager to the DevOps engineer. uh, how feasibility is for me. I have a
Yeah,
less
you are in a
coding.
you are in a very good position, Madhu, to switch. Okay, because you already know how the underlying software development lifecycle works, how are the things in the IT organizations. Now you just need to apply these principles to cloud. Okay, and also, of course, I would say, I mean, you're almost my age, maybe probably the same age. So you might have your family and other things, but why am I highlighting this point is you will have to spend a lot of quality time, even during the course and also after the course, to be prepared for the job. All right, so that's when you can solidly prove, because your experience is high. You cannot say that you have only, I mean, you could say something like this: you have 10 years of testing experience, quality assurance, and the last 5 years you could say you worked on DevOps. Okay, but to prove that you worked as 5 years on DevOps, you need to have that confidence. That confidence only comes with practice, practice, practice. Okay, and also, as I said, some many people has asked, like, what about the VPN integrations? What about these integrations, that integrations? We cannot cover all these things within this short duration of this course. So those things, some of those things, you have to go through your blogs, videos. AWS or Azure, they hold their conferences which are available on YouTube. You can watch them, you can read blogs, you can listen to podcasts, you can do all these, and you can gain uh, this knowledge after the course or also during the course, and based on all these things you will apply for your jobs. Okay, so yeah, there is a lot more to cover even after the course, I will be honest, but this will be the right foundation for you, because once you complete the course, you'll get more confidence, you'll understand what others are talking about. Okay, when you hear things like hybrid model, VPC, VPN, you will understand what each of these things mean. Okay, there are two questions. One by Ramesh. How much is the fee? Yeah, you just need to contact that number, Ramesh. Uh, uh, you can speak to my colleagues in Career IT. They will help you. I'm pasting that message again. Uh, admin, I'm not sure whose admin he is, but he's asking me a question. May I know the reason behind why not AWS DevOps instead of Azure DevOps? Right, very good question. We have both AWS DevOps and Azure DevOps from Career IT. All right. Uh, we have started earlier. There was AWS exclusive course and AWS with DevOps also. We still have AWS with DevOps. You can contact those numbers and they will give you the details when the next batch is starting. But we started Azure DevOps almost 1.5 years ago, because there's more demand for DevOps engineers with Azure knowledge, and market has less people because a lot of people have learned on AWS but less people on Azure. So that's why we started DevOps with Azure. Okay. Yeah, but you also have DevOps with AWS. Just contact that number. There's a lot of
Hi,
demand and
Kiran.
less number of people for
Krishna.
Azure. Yeah, go on, Krishna, please.
I'm sorry. Yeah, thanks. Actually, I have a 13 years experience in a production support. I'm working in a content management services like Teamspeak and Bloomberg.
Okay.
So, I mean, production support, I worked in like WebLogic and those kind of things. Now we are
Right.
migrated to Azure. I mean, how can I fit for that? Is there any, I mean, can you give me some suggestion for that, so that actually I would like to learn that Azure only, but I'm
Yeah.
not sure where I can fit it.
Yeah, the
I mean,
same thing
if I
applies.
want to switch my job, yeah, go ahead, sir.
Yeah, the same thing applies as to Madhu, right? Okay, Madhu said he has 15 years experience in quality testing management. Okay, quality assurance. So you have content management and some production support. So you have good platform. Okay, so this will give you the basis. You will understand what is Azure Access Management, many things which could be used for you. Even if you are working on a production management in Azure, this will give you an advantage over others. Maybe if you're planning to switch organizations also, this will give you the right platform. But as I said, to justify to your experience, to justify to your cloud ops or cloud and DevOps experience, you will need little more practice. Like, some things are expected from junior DevOps, some things are expected from senior DevOps engineers, right? You agree, right? So when people like, people with more than 13 years of experience are applying, and you may say that for the past 3 years you're working in a DevOps role, particularly when you're trying to shift roles, shift organizations, you have to give them the confidence that you have worked on these things. For that, you need to really have good grip on the practicals. Okay, and also you you need not be a 10 out of 10 on all these services. You could be like 8 out of 10 on Terraform, let's say 6 out of 10 on Ansible, a little bit on monitoring, let's say 7 out of 10 on Azure DevOps or CI/CD tools. So that should be good. But some are very important things these days. Okay, you need to be strong with your operating system knowledge. Okay, you need to be good with source code management. We will spend good amount of time on Git and GitHub. Okay, after a certain, so how are we going to do is, once we learn the basics of virtual machines and Linux operating system, we're going to learn Terraform. From there, if you want to learn even Ansible to create the demo machines also, we'll use Terraform. So incrementally, we'll use all these things. So once we learn Ansible, we'll apply Ansible in Azure DevOps. Okay, I mean, combine Azure DevOps with Ansible for some of the tasks. Okay, so in this way, we are going to learn incrementally, and every stage, once we learn the basics, we're going to start using source code management, and you'll get more idea about these things. Okay, so that will definitely put you in a very good position.
Thank you.
Okay,
Thanks,
so
Karan.
to just, yeah, you're welcome. So to conclude, this is what I want to say. So it's all about learning, implementing, and excelling. So to go to the next level, you have to implement. All right. So this course is designed both for freshers. You could be fresher to IT industry or a complete fresher also. And for those already working in IT, as I said, there are no prerequisites. And we cover a wide variety of processes and technologies. This aims to equip you with right amount of theoretical and practical knowledge, but I would say we are more inclined towards hands-on practical classes only, less of theory. Okay, so you will do a lot of typing in your practice also. I will do a lot of typing while I'm teaching also, not just going through PowerPoints, very less PowerPoints in fact. um, while this course offers a lot to learn and upskill, it's about your enthusiasm, your hunger, your appetite to learn and take it to your next level. All right, so thanks everyone for joining. If you do not have any further questions, of course, I'm already late for my meeting by 17 minutes. Yeah. If you do not have any questions, we can call it off.
Hello.
If you have questions, I can stay for next 2 minutes. Yeah, please go on.
Yeah, I'm Satish Kiran, and I'm having 5 years of experience. And
Mhm.
after this course, can we get any real-time projects?
See,
Can we
you
learn
know,
any real-time?
you can learn real time only when you're working in a real time organization. That's my experience. Let me be very honest. Okay, but I can take you as close as how it looks in the real time environment. That's what I can do. Okay, I cannot give you the real time projects.
Uh,
Okay, because I cannot set up that kind of environment, or no one can set up. You cannot hire developers and create that, but we will go as close to the real time as possible. Okay, and also when we are learning, we will not learn from how a company looks like, but we have to break everything into bits and pieces, right? So to learn sentences, you need words. To write words, you need letters. So we'll starting from letters, right? So
yes.
later, it's up to you to form these letters. Okay, by practicing, of course. I'll also help you form the minimum letters. Like, we'll do minimum CI/CD. We'll take a sample application and deploy in our servers. Okay, and we'll do how you can create a website and open it in your browser with the website. How load balancers works. This is what happens in real time, but we will not do the exact real time scenario. You cannot replicate, in my experience. Okay, we can take it as close as possible to the real time. That's it.
Okay, Kiran.
Yep.
Thank you.
Thank you, Kiran.
Thank you, everyone. Thanks for joining on a weekend. Hoping to see you very soon. You all have a good weekend. Stay home, stay safe. It's another question. I'm not sure if Gautam is. There is another question. Not sure if Gautam is still on the line. There is some overlap. Yeah, the services are similar, but the implementation is slightly different. We'll do some comparison also sometimes. I don't give any live labs. You can do your labs on Azure. Azure gives us free infrastructure anyway. I think Gautam has already dropped off, but anyway. All right, folks. Take care. Bye bye.